Happy Friday. All right, everybody left comments, or majority left comments wanting to see some machining. So in this video, first I'm going to show a mystery tool, asking you guys for help if anybody knows what it is. And then I'm making a little clamp mechanism here for the 3-axis CNC, and at the end, I'll summarize it at the end, but having a blast with this thing. So let me take you over to the bench and show you the mystery tool. Not sure what in the world this thing is. Found it at a pawn shop for $2. Said, all right, let me get it and see what in the world. Sharper than all get out, let me tell you. It does take plastic off real quick and shoves it up here. But I'm thinking too, the way it's got this hole in here, there probably was something rod down here, and I bet you this was in a machine where it punched something, and as it came up, the rod pushed it off the edge. But if anybody has any clues as to what this is, please leave a comment, because this is a kick. I don't know. Not sure what I'm going to do with it, but I guess $2, why not? Also was playing around with FreeCAD, and I had a 1mm end mill, but it wasn't long enough to go completely through the plastic. But my idea was, I think one of these is the 30. Yeah, this is the 30. It reproduced this perfectly. So I can make gears this way for the mini lathe. Just need to get some thick plastic and find a cutter, but for what it's worth, I did order one gear cutter to do the pitch on this. So I'll wind up doing a video here, I guess, coming up, talking about gears and how to make them. Like, it's probably guaranteed going to be another Me Too. The interesting thing too is you look at these gears and they mesh nicely, but boy, if you hold this up to the light and look through it, it's the worst mesh I've ever seen. But I'll be getting into that. So tried, this is like acrylic. I think that's acrylic. Doesn't say anything. Yeah, not really. This cuts nicely. I tried this plastic, and just kind of melts it and pushes it out of the way. So it'd be nice if I could find this real thick, make my own gears, or I don't know. I haven't really tried aluminum yet on the 3-axis mill machine. First, I'm going to talk about this chuck for a minute. I had two chucks. There was one that came with this machine, and then there's one I had bought for $12 or $13 off Amazon, and that was the one that I used I think this was 5mm, right? Yeah, that's the one that I used a 5mm end mill, and just kind of went down in and opened it up just slightly so I could force it and get it on, and then use the Allens to lock it in place. Turns out, playing with this machine, almost any cutter I put in there, I could see it wobbling. This one doesn't, but I'll tell you why. I could see runout on it pretty bad. I think it was like 6-7 thousandths. So evidently, I didn't do a very good job or something in boring it out. Turns out I've got two 5mm end mills. One doesn't go in there at all. This one, or this type from Banggood, did go in. So one of them's just a hair under 5 or whatever, so do it. So I had removed that chuck, and then I did what you're supposed to do. I took the chuck that came with the machine, heated it up with the torch, got it on there, and it went all the way up too. I couldn't back it off in time because I wanted a slight gap up here. That one also had some pretty bad runout, so now it's like great. So where'd this chuck come from now? Yeah, now I'm lost. So this might be the first one again. No, because I can't get it on any further. I have another chuck. Oh, okay. So the one, yeah, that I heated up and put on there, it didn't work either. It had run out. So now I'm figuring, how do I get it off? I tried heating it here as hot as I could, you know, a hot flame, and figuring I could slide it off, but no, it wouldn't come off. So I took the whole assembly out. I found a wrench, open-end wrench that would go in here, put it in the vise, and I could, with a punch, hammer the shaft out. So now I've got that chuck off. And that's the one then I tried doing the end mill again, and this time I was successful. So now I've got a nice chuck, no run out, it captures everything, the collets work, so okay. I just wanted to talk about that for a minute. Now, everybody's seen these clamps that I've been using to hold things down, and I was thinking, why don't I make something? And I have a piece of 3/8 by 1 inch. What happens if I do cut this and then put the slot nuts, T-slot nuts underneath, and just keep this permanent, and then put a little down over. So now I'll have something absolutely square, because I can put a test indicator on the head and run it back and forth. So now I have something that I can leave permanently, and I can square things up to, because right now all I'm doing is just kind of eyeballing it to these slots. And then with that notch, there's things like plastic or whatever where I want to go all the way through. I can set it in well, to do this one, I had to put a piece of wood down, put this on top of it, and then go through into the wood. But now I'm thinking I can just set the material in this, and it'll be off the table, and I can now look underneath and I can see when it actually breaks through without going into my table. And I was thinking, the gears for the lathe, I could make that 60-tooth gear, and I could probably make all the other gears and be able to do some metric threading, which I haven't done. So I was looking at this thinking, 1 inch might be too big. So yesterday I picked up 2 3/4 by 3/8 pieces, which I think is going to work. And 6 inches hits the back and hits the front, which I know is higher than the rest of the table. So I think I'm just going to cut this guy in half, dress up the ends. Can I see underneath there? Yeah, I can see light through there right now. So I'm going to wind up coming back here, and I'd like to get the T-nuts here and in the front, but I don't know what that's going to look like. I don't know, maybe just let it be over there, because here's a 6-inch ruler. It kind of just, I'm going to try the 6-inch first. So let me cut this in half, 12-inch. And a lot of people ask me, the new people, where do I get my material from? I've got a local metal supply house, industrial metal supply, that I can go to, and they have pre-cut material, 60, 61 steel, 1018, a bunch of things, pre-cut, 12 inches, that you can just buy off the shelf. There's racks of all this stuff, all kinds of sizes, and they also have 2-foot long stock that you can buy. So this was like $1 each. So for the new guy, go and look for your local, if you have one, a local metal supply house. If you don't, eBay is my second choice. I bought stuff from this guy called 6061 Dude. Look for him on eBay, and you'll be able to get material there. I've also gotten some material off of Amazon, but nowadays it doesn't look like it's very inexpensive. So let me cut this one off. I think I'm going to go with this, because this seems like that's, you know, pretty wide. Because after this notch is in here, it's going to be tiny. Then I still have room to put a socket head in there. Because these are, how big is that? Yeah, that should work nicely. So, all right, let me cut this off. Well, everybody wanted to see the more machining, so got to say, I've got a spare piece here. I'm gonna have to hacksaw it in half by hand and finish it up as a T-slot nut. So to just face this stuff off, it's really easy. Just basically bring my favorite Travers end mill down and lock the head, eyeball it. Yeah, I'm further down than I need. So I'll just go back and forth until it starts to clean up. And then for conventional milling, I don't know how, I've seen some machines do conventional, get a gorgeous finish. No matter what I do or what cutter I'm using, I cannot get a nice finish doing conventional. So it'll be climb milling at the end. Take my RPM up to about 3/4. I mean, it's not really a screaming speed. Turn this light this way. Maybe that's pretty good for you guys. I don't know. Alright, so come in to touch. So I'll just do this one side of this piece, one side of the other piece, and then I'll put both of them together and do the other side both at the same time, so they're the exact same length. Alright, is this taking junk off? Yeah. Digging in pretty good. That sucker is crooked. So industrial metal supply, your saw is way off. And I'm going in about 4 thousandths. Yeah, it looks like that's pretty close to being done. Or what I mean is the entire surface is being cut. Nope, I can still see some stuff on the bottom. Might be able to call this one complete. I like to go around and look at it before going backwards. Can I see it? Yeah, just to be safe. For the final cut, again, nice finish, doing climb milling, 2000s. There's 2. And move it away from the cutter, back it up, and shut it off so you guys can see the finish. It's pretty, I can look at the cutter and the reflection. Oh, not quite there. Yuck. Alright, well, that's the idea, so I'm just going to do the rest of it off camera. Okay, I've got the 2 pieces here done. And I was just looking at it and kind of eyeballing with this cap head screw. So I think I'm going to put it like this rather than cutting them any shorter. I've got some measuring to do between, you know, here and all this and the math to figure out where exactly to drill the holes. So that'll work, I think. This one, yeah, this is going to be shorter. I want this to be down on that. Actually, I don't know if this, yeah, I'm going to have to use the machine to see if this height is the same as that height. Actually, it probably doesn't matter. This machine isn't really that accurate or super duper. So, yeah, I can still see light under there. Can I see it under the back one? Yeah, same gap. But with me, finishes, I'm real picky about finishes and look. So, rather than taking out the face mill and taking it down, I'm looking at this material going, this sucker is pretty darn smooth and flat. It's nice extrusion. So I think I'm just going to try see what it looks like. Take this to the belt sander and run both sides over, and I think it's going to come out pretty good, because eventually what I want to do is I'm just going to heavy chamfer this side, the back, and that, because this is going to, do I want to? No, because it's going to be a groove all the way down, and I want a sharp edge. So the edge that's going to be right here, I'm going to break with the stone. And the idea is this guy gets clamped permanently way over here someplace. I'm going to have to make another one. This guy will have the groove in it, so I can put the material down here, push this up against it. I'll snug up 2 T-nuts, and then I'll have another one here that'll be clamped in place with some kind of screws that just push it and hold it against the material, and then tighten these up. Not sure exactly how well it's going to work, but I think it's worth a try. You can see it hits his back piece. And I'm playing with the plastic, and I don't think, if it's suspended up in the air and getting clamped, I don't think it's gonna bow. So we'll see. Some of it I don't think matters if it bows slightly. I mean, that stuff, it's bowing a bit, but I really have to push on it. So again, it's an experiment. Let me see what the finish is going to turn out like here. Just as I suspected, it did a great job on all sides. I'm kind of looking in the camera to see if you guys can see that finish on it. Forgot what's on the belt sander. I think it's 600. It's a pretty coarse stuff. But also, if you can see the difference, this is no oils on it. Second you put oil on it, it completely changes the look of it. It looks finer, and black and junk comes off on the paper towel. But I'm liking it. And if I want 600 grit on the granite surface with WD-40, I could lap it and it'll come out even finer looking, but I'm happy with that finish right now. So now I just need to do the math and set up to drill the holes. I wish I could get in closer with the camera. This light's probably, I could probably do everything without this light. I was starting to mount up the edge finder because I was going to drill the holes, and I was thinking, okay, edge find, because I need to put it on center. It's like, no, I need to put it on center after the groove is done. So put a 3/8 end mill in there, and what I'm going to do is I need to touch this side, zero out the DRO, touch the top, zero out the DRO, and I was measuring this guy, just kind of looking at this, how deep this is to be able to capture something. And I was shocked because I was thinking, oh yeah, 100 thousandths would be perfect. That is 100 thousandths. So I'm going to try to do this 150 thousandths. Come on over, touch the surface and lock the Z-axis into fine. So that's probably zero out the Z right now. There's zero. So I need to just come down a little bit to touch and zero out Y. Am I far enough back? Yeah. So this is kind of simple again. It's like the knob is 3/4 up for speed. Let's see here. I'm gonna need a bit of light here to be able to see when the chips start flying. Alright. There. Okay, Y-axis, zero it out. Back it up. I'm gonna go down 140, I guess. 70, 90, because I want room to make a finishing cut. 39 is 140. Just turn the Z off to save the battery right now. And yeah, it's looking pretty good. A lot of this again is flying by the seat of my pants. I got to take light cuts because I am up on my highest parallels, which isn't clamping it very much. So it's just a matter of going back and forth and back and forth. And this piece is a little bit under 6 inches. Wow, it's hitting all the way down, so it's pretty straight after messing with. Oh yeah, I looked up the sandpaper on the belt sander. It's 130 grit that gave this finish. Look, it's taking chips off all the way down. How nice. And I'm in 2000s, so that's not much. So I'll be taking probably 4,000 cuts. Let me try it. I'm back. Oh, I was off. I was -2. Well, here's 5. So there's a 5,000 cut. So it doesn't matter on this. I'm held pretty good, so I can do climb or conventional. Climb, it would want to be pulling this work into the cutter if anything goes wrong, and everything would come flying out of the vise. But so I'm going to go in 150 and then down 150. So bring you guys back, and I've got it up on the highest parallels because I want to do the chamfering after this, and I'll be all set up for it. Well, I'm going to do the drilling and then chamfering. All right, well, that's a 7,000 cut actually. Okay, down 150, and I actually just decided to quit at 130 back. So now I can find the center here. Everybody's, I still have the power feed engaged. So I gotta disengage it to do this. Actually, I'll just come over right now. Man, I don't know. I've done a lot of work on this power feed. It's still hanging. Oh, there it is. I'm looking underneath for the set screw to disengage it. So, alright, I gotta be careful with this guy because I don't want to whack him. So, come there, I'm just gonna lock it, back it out. Not a whole lot of RPM. Everybody's shown edge finders before. You just go in until it snaps. And again, I've said it many a time, do not put oil on it. It just doesn't work anymore. And I've tried, you can't get the oil off of it. So you just come in real slow until the thing snaps. Boom, here it is. So, Y-axis, zero it, back away. And this is where I like the blue DRO, because I would just hit the button and do the math for me, divide it in half, and then I find center, but still have to get more of that thing working. And same thing, the other side, just, too fast. Come in, oh yeah, way too fast. All right, slower, Dave. Not critical, there. So, 818 divided by 2, and I'll be on center. Okay, easy enough to do, you know. Found the center, edge fine, divided by 2, edge this, edge the other side, get the center. Math says I need to move over from center 2.657. So I'm there. This is the drill hog set that I showed in one video off eBay, and the reason I'm using it is it's split point, so it's not going to walk because I'm too lazy to center drill everything. So I'm all set for just drilling the first hole, then I just got to move it over the other way, same dimension, and I'll be set. And I love these drill hogs, and it's kind of crazy, guaranteed. Oh, it's wobbling some. There's my chuck. I could try reseating that, see if that gets rid of it. There. What does that do? Better. And just for the heck of it, use a little A9 in there. Low RPM, just go down in. Look at how the chips change real quick when you have cutting fluid in there. Welton A9. Nice, clean hole, shiny side, everything. Of course, these chips are going to screw the side up soon because they're going to start scraping it and then you don't have a nice finish. But maybe if I just keep relieving it. Then I guess I'll just hand chamfer these holes to clean up both sides. I guess I could probably go by the book and set the RPM right for doing this. Boy, that's deep. Oh, that hole still looks gorgeous. Wow. Oops. Wow, taking forever to get down there, huh? There, it's going through now. Alright, yep, it screwed up the sides, but whatever. So that's it. I'm just going to move to the other side and then I'll come back and show some chamfering. Trying to get the camera down in closer so you can see this, which is not easy to do. Yeah, you're probably wondering about this tool. In an upcoming video here, I'm hoping to do a comparison of chamfering tools. This was a set that I had picked up off of Banggood, and it turns out to be really nice. I played with it a little bit, but oh, let me make sure I don't go right into my vise. So this is the first time I'm actually really using it on something other than playing around to see how the finish is going to be. Alright, so that's pretty good. I'm almost to center on that thing. And is it going to hit? No, I'm very close. For these guys, I like running at full RPM. Alright, come on up. Yeah, there we go. At least the belt drive upgrade is on the slowest, but so I'm going to come in until I just start seeing chips come off of it, and then that it? No. Yeah, that's it. Then zero out the DRL, and I think I'm just going to go for like a 10 thousandths cut. Let's go 5. There's 5. Because I'm conventional, which isn't going to give a nice finish at all right now. Yeah. 10 might be it, or 15 is kind of what I found for me personally that's nice. Oh, I'm doing this there, I'm going to see just how flat the top is. Because if it gets wider, it's looking very even. I'm surprised. Might be getting, hard to tell. I think it's the same, which is great for me, you know. Alright, so that's 5. Let's go into 10. 8, 9, 10, and I'm going to lock that axis so it doesn't move. This would be better with the power feed, but I'm just doing it by hand. Oh yeah, 10 looks perfect. Alright, so I'm hoping you guys can see that. This little guy is giving a gorgeous finish, even though I'm doing this by hand, so I'm jerking the table around a few billionths of an inch. I'm just loving this finish. I'll try moving the light around to see. Wow. Let's see if I can change this at all so you guys can see a reflection of it. But that's a gorgeous finish, and these things, I'll put a link to it for now for what it's worth in the description. I think it was like a $6 or $10 set or something. It's great. Wow, that is gorgeous. Alright. Maybe. Yeah, I see some ripples in it. I'll try moving the light all around. I don't know what you guys are gonna... Yeah, you probably is best. Yeah, okay. So I just need to chamfer this and the back, and this guy is done for now. Alright, this is pretty easy to do. Here to here, edge finder, find center, edge to edge, find center, come over. What was it? I had calculated 2.657, so I'm on center. 8 millimeter is going to work for this guy. I just need to figure out how deep I gotta go here. Alright, it's zero. Oh, it doesn't zero out 3,000. So I'll clean it. Now it zeros. I need to go down and I want it real flush, so 0.188. 0.188. So come down, zero out the ZDRL, and I think I want to use the fine feed for this to see what it's going to do. I'm up 34 thousandths. That is really tight in the vise, right? Yep, nice and tight. Alright, so 1,000. So yeah, I'm hitting. There we go. 0.188, huh? Alright, 10, 15, 20. That's pretty deep, huh? You probably should slow that down a bit, but 50 thousandths. 60, 70, 80. I'm gonna back up just to double check this. There's 100 thousandths. Because that seems like I went in a long ways. Nope, I guess not, huh? Light for me. Uh-huh. Right, double check that measurement so I don't mess up. Yeah, 0.188. Sure seems like I'm going a long ways in there. Trust it or not? Actually, if I go back down to 0, I should be right on the surface. 1, 0. Yep, I'm pretty much so right on the surface, so trust it. Here goes nothing. At 0.1, I should start cutting again. 70, 80, 99, yeah, alright. Trust it. 188, 20, 30, wow, 40, 50, 60, 70, jeez, I'm scary, 81, 3, 5, 6, 7, 8. Does it work? Right on it, baby. Love it when it works. Okay, so I've got this one and then the other one to do. Okay, you can see it's kind of set up here. Looks pretty nice. Maxwell's little silver hammer here to whack it around. Snug up the back. Pretty more tighter than the front because I'm going to tap the front. So I tap the front and the back, and you can see, I know the camera's at an angle and the light may not be that hot, but let's see, send the head back. So it's dialed in. It's within 1/10 or so. If that, I don't even really see it moving. So I've got one nice square edge here that I can put things up against. Dust all over the place. So I can clamp down here or I can sit it up here. Now this piece, I just need to figure out how I want to do this, and I'm pretty sure I don't want this to be on the two top pieces. I think I want it in here. And I was thinking about springs in here. I don't know, because I can bring it up, compress the springs, lock it down, and then it's got force on this, and then I can lock this guy down. So I don't know, I still got to think about it. this being so thin or low profile, it's going to be tough to put screws. Yeah, I was originally thinking just Allen's, or yeah, more cap screws or something, and you just push it until you have force on it and then clamp these down. So I just got to think about it and do this last part, and that'll be it. So cool. Hey, I'm gonna call it quits right there. So I did some playing around here where you just push that in as hard as you can and then lock it. But this, I also had a piece of aluminum in here. It just lifts right up. So for now, I think I've got a nice square edge to work against. I go down below, I go up high, and I'll probably move this in further, because then I can come in with the clamps here, which go over. Let's see, come on, get in there. Yeah, there. So I can come in with the clamps and bring this back up here a bit there. So I can come in with the clamps and just hold it down. The other idea was just drill and tap a bunch of holes and then put the clamp straight on there. But until I come up with a wonderful, ingenious idea, is why I'm going to say, okay, quits for now. So it's a nice setup here for getting it off the table and also squaring and putting it down on the table. May have to have little blocks or something if I'm down low, because the clamps aren't going to, this is all loose, yeah. Yeah, clamps aren't going to make it way down here, but hopefully I'll be machining some thick material. But yeah, I can come in like this and just put a spacer or something under there. So I'll be moving this over to allow stuff to come in here. Probably center it up. So I've got the same gap here and the same gap here. And just work with that for now, but that's it, huh?